Chapter 10: Hurricanes and Extratropical Cyclones. Welcome to Hurricanes and Extratropical Cyclones. Though this natural hazard rarely affects Idaho, many of you are interested in them due to the news coverage they get. Most semesters, I have someone wanting to do their class project on Hurricane Katrina or other major tropical cyclones. And most semesters, if we have run out of time and not covered cyclones, they are not entirely accurate on the physical processes that cause these awesome hazards. So we are going to explore the cyclone hazard and learn why and how they occur. And if you choose to do your class project on Hurricane Katrina, I hope you correctly explain the physical processes. 10.1 Introduction to Cyclones. Cyclones are an area or center of low pressure with inward rotating winds. They are counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Why do the winds rotate? Remember the Coriolis effect. Look at the picture. We have a low pressure in the middle. In fact, the pressure gradient indicated by the blue arrows shows that we have higher pressure on the outside and lower pressure towards the core. And so what type of air is in the middle? Is it cold and dry? No. I hope I didn't trick you. Low pressure is associated with air that is warm and moist. It wants to rise, so low pressure on the surface. As the warm, moist air rises, does it create a vacuum? Nope. Air flows in. Remember, air flows from high pressure to low pressure. So air flows into the low pressure core, deflected in a circular manner around the low pressure core due to the Coriolis effect, as indicated by the red arrows. And voila, we have a cyclone. Okay, it's a bit more complicated, but that is the general idea. Is the picture of the cyclone in the northern or southern hemisphere? Deflection is to the right. Counterclockwise rotation. We are in the northern. Tropical cyclones form over warm tropical or subtropical ocean water, typically between 5 degrees and 20 degrees north or south latitude. They include tropical depressions, tropical storms, and hurricanes. They produce high winds, heavy rain, surges, and tornadoes. They derive energy from warm ocean water and latent heat of condensation and have warm central cores. Picture on the bottom left is of a hurricane being fed by warm ocean waters. In fact, the orange and red colors of the ocean indicate that the waters are greater than 82 degrees Fahrenheit. No wetsuit required. The cartoon to the right depicts 5 stages in tropical cyclone development. 1. Warm, moist air moves over the ocean. It is warm and moist because the ocean is warm and wet. 2. Water vapor rises into the atmosphere. And 3. As the water vapor rises, it cools and condenses into liquid droplets. 4. Releasing the latent heat of condensation in the atmosphere, making the air less dense and causing it to rise, baby, rise. And 5. The warmed air continues to rise with moist air from the ocean surface flowing into the low pressure core, creating more and more and more wind. In contrast, we have extratropical cyclones. They form over land or water in temperate regions, typically between 30 degrees and 70 degrees north or south latitude. Like tropical cyclones, they produce strong windstorms, heavy rains, surges, and tornadoes, but unlike tropical cyclones, They can also produce snowstorms, blizzards, and severe thunderstorms. However, most extratropical cyclones do not produce severe weather. They derive energy from temperature contrasts along fronts and are associated with fronts and cool central cores. Below is a picture of an extratropical cyclone centered over the Great Lakes region. Look at the size of it. What areas are being affected by this extratropical cyclone? To me, it looks like the extratropical cyclone is dominating the weather from about northern Louisiana up to Hudson Bay and from Montana to the Atlantic. Now that's pretty big. Here are two weather maps, one of a tropical cyclone and one of an extratropical cyclone. Can you tell which is which? The colors indicate temperature, with warm temps represented by warm colors. The dark lines are isobars, lines representing the pressure contours or areas of the same pressure. Can you tell which is which? Did you get it right? Tropical cyclone on the left, with a warm central core. It's Hurricane Katrina. Extratropical cyclone on the right, with its cool central core. Both have similar low pressures at the center. Notice that the tropical cyclone has kind of a bullseye pattern of temperatures, cool to warm, from further outside to the core. The extratropical cyclone has a cold, warm, and stationary front, so temperatures are colder behind the cold front and warmer behind the warm front. These temperature patterns are integral in how the cyclones form. Cyclones are characterized by intensity, meaning their sustained wind speeds and lowest atmospheric temperature. The Saffir-Simpson scale classifies hurricanes based on highest 1-minute average wind speed and was first used in 1975. Here's a fun table of the Saffir-Simpson hurricane intensity scale. Notice that the storm surge, the wind speed, and the destruction increase with increased numerical value. Also noticed that the core pressure decreases with increasing numerical value. Major hurricanes are category 3 through 5. Okay, take a moment to read the table. A similar one is found in your book or online. At what category are the friendly, natural hazard prone trailer park homes going to get obliterated? I got category 3. Did you? Now, why have I been saying tropical cyclones and occasionally hurricanes? Well, there are lots of names for tropical cyclones, including hurricanes, typhoons, and plain old cyclones. Hurricanes are tropical cyclones in the Atlantic and Eastern Pacific Oceans. The word is from the Caribbean word for an evil god of winds and destruction. Typhoons are tropical cyclones in the Pacific Ocean, west of the international dateline and north of the equator, and is from the Chinese word for scary wind, or wind from 4 directions. Cyclones are tropical cyclones in the Indian Ocean and is from the Greek word for coil of a snake. So there you go. As far as physical processes are concerned, a hurricane is the same as typhoon or cyclone or tropical cyclone. Warning: in this chapter I will use the word cyclone when referring to both tropical and extratropical cyclones. In general, I will refer to fully developed tropical cyclones as hurricanes. If I am talking exclusively about extratropical cyclones, I will say extratropical cyclones or extratropical storms. Got it? So before we move on, there are two pictures of tropical cyclones on the right. Which one is in the northern hemisphere and which one is in the southern hemisphere? Top one looks like counterclockwise rotation to me, so northern hemisphere. The bottom one has clockwise rotation, so southern hemisphere. Neat. I hope you got it right. Hurricanes, named by international agreement through World Meteorological Organization. They are named once winds exceed 63 kilometers, 39 miles per hour. Names are assigned sequentially each year from list for each origin, with male-female names alternated. Names are reused every 6 years, and the names of big storms get retired. Example, Katrina. If they run out of names in any given year, such as in 2005, they go on to Greek letters. Here is a list of names for Atlantic hurricanes from 2015 to 2020. Is your name on the list? My name is in 2019. I hope I make the news. Extratropical storms don't usually get a specific name, but are generally named after their origins, such as Alberta Clipper or Nor'easter, which was discussed in a previous chapter. The picture on the bottom left is of a nor'easter, as the winds are coming from the northeast when the storm hits land. The top right image is of storm surges associated with a nor'easter, and the bottom image is of the snow dump from a blizzard from a nor'easter. Nor'easter, nor'easter, nor'easter. Extratropical cyclone. Here's a map that you've seen before, showing the general tracks and names of some extratropical cyclones. We've got a nor'easter track in red in the south and up the east coast, and an Alberta Clipper track in blue in the north. (10.2) Cyclone development and movement. We'll cover tropical cyclones first. The tropical cyclones usually begin as a tropical disturbance, forming into a tropical depression, as in depressed or low pressure, not emotionally sad, then developing into a tropical storm, and then intensifying into a hurricane. A tropical disturbance is defined as an organized mass of thunderstorms persisting for greater than 24 hours. The mass of unstable air is big, typically 200 to 600 kilometers, or 120 to 370 miles wide. There is a weak rotation of the air due to the Coriolis effect. Tropical disturbances form in a variety of waves, including lines of convection of air, upper-level low-pressure troughs, cold front remnants, and easterly waves of converging and diverging winds. The easterly waves of converging and diverging winds is a favorite way of tropical disturbance formation in the Atlantic Ocean. As the winds develop, spin on the inside of the upwards wiggle of the easterly waves, or, in other words, near the low-pressure trough. This spin draws warm, moist air from the surface up into cooler air aloft, causing condensation, etc. The map on the top shows how easterly waves of convergence and divergence across the Atlantic can form a low-pressure trough that can become the low-pressure core of a tropical storm, and even a hurricane. The picture on the bottom is of the African easterly waves, with several storms developing at the inside of the upward wiggle. There is even a tropical cyclone on the far left.